afternoon, everyone, and welcome to today's latest Technical Tuesdays ECA webinar series, exclusively for ECA members. Today, we're joined by our technical manager, Darren Crannis, who is here to talk to you today about protective devices for net zero carbon technologies, including solar PV, battery and energy storage systems, much more. If you came along to our Net Zero Roadshow last year, you may already be familiar with some of these technologies. So here's a more in-depth look with Darren. We are open for questions at any point during the webinar. Just use the question mark button that should be up on your screen now in the control panel, and we'll get to as many questions as we can at the end of the webinar. That's it from me. Over to you, Darren.
Thank you, Omar, and welcome to everybody for this one of many Technical Tuesdays we're running. You may have seen us previously. We're doing a lot of demystifying, so we've done sort of demystifying electric vehicles. So we're going to brush a little bit onto that as well today with these protected devices. So the whole idea for today is to go over looking at protected devices, especially when we've got a lot of net zero carbon technologies. We like to call it electrification, but we'll just stick with net zero for now. So we're going to dive into some details on that one. So what we're going to go through today, a little bit of introduction really of why we're doing this. We're going to talk about power, how it flows, energy flow, especially with net zero carbon technologies. We know this isn't just a one direction now, and that's not a plug to the band. Okay, we know that energy flow goes in two ways, so we need to look out for that, and that's predominantly where this presentation came from. We're going to look at protection for circuits that we use for net zero carbon technologies. And there are many different types out there. We need to make sure we got the right circuit protection for that. We'll briefly look at protection for other circuits. You know, protection devices aren't just for AC circuits too. We have many others. And then we'll go and wrap this up and go into our Q&A. So really now, just setting the scene for you all. Net zero technology is the biggest invention since the light bulb. So for hundreds of years, we were just installing standard circuits. Now it's more complex, just sockets and lights. There is some confusion in the market with designers around the suitability of protected devices. So we're going to hone in a little bit on that today. We're also going to look at, are RCDs always required? There are a lot of additional protection out there. Many special areas require additional protection, but do we require this for all net zero carbon technologies? We'll take a little dip into that as well. Do we need to verify automatic disconnection of supply, ADS or EBADS, if you go back that way? So we should be doing this. We'll touch on that and why later on. And we'll look at some of the requirements which the British standard looks at, BS 7671, and we'll touch on the proposed amendments. So we've just gone through the draft for public comment stage, DPC side on Amendment 3. So first of all, let's have a little look at direction of power, or where voltage lies, and let's see why that's really important. Traditionally, as we've already mentioned, power flow was always one way. Okay, it was we were mostly consuming current using devices is what we refer to them as. But with the advent of alternative supplies, sort of solar PV, energy storage systems, bidirectional power flow is a thing. Goes in and out of a source, goes in and out of your installation. And importantly, and this has always been the case, the way the regulations are written, that circuit protection will only function correctly and effectively if it's connected correctly. And that's always been the case. And that's always been there with regulations 134.1.1 and 510.3. And we shall take account of manufacturer's instructions. But again, you know, our installations have become much more complex now. So for the first time in hundreds of years, we are using energy, storing energy, utilizing energy in many different ways. And our protected devices still need to do that job. They need to protect us and the installation. So we've got a little scenario here of how energy does flow. sort of typically around our sort of home networks there. Okay, the first one you'll see, prosumers, electrical installation. So this is prosumers taken from the grid as well. And you can see the solar's generating, the battery's charging up and discharging, but we're still taking energy from the grid. There might be reverse mode. So therefore we've got all the energy we need. We're now just giving that back to the grid. And then we got island mode. And we'll touch on this a bit shortly as well, where we want nothing to do with the grid anymore. We're self-sufficient. So now we're just relying on our solar and battery source. So in 20 years, we've become our own power sources. You know, we don't rely on the grid anymore. We need to make sure that all our protection works. And being in island mode also does have its challenges as well. So direction of power, all generators, okay, including solar PV and electrical energy storage systems. We need to consider that energy flows both ways. And why is this important? Well, especially if we look at solar PV, for example, we know this as what we call PECs, which is power electronic converter systems, or commonly known as the inverter. So we'll just call it the inverter for now. And they are designed to shut down. So where we're looking at, why do you say, why have we got bidirectional flow to a solar PV system? Surely that is just generating all the time and we're just taking it. It's not like we're pushing, you know, electrons back up the wire and it's admitting sunlight into our atmosphere, which would be great on a day like today, but unfortunately that's not the case. Okay, we take from the sun, it comes down. But where we can possibly have problems with protected devices is where the voltage sits after what we call loss of mains. So if there's a loss of mains incident, either the protected device trips, so it opens, or you lose your connection to the grid with a solar PV system, the loss of mains is triggered in that PV inverter. And, you know, according to engineering requirements G98, which you might be familiar with, it can take half a second for that inverter to shut down completely to a safe level. Some older inverters will keep generating for 2.5 seconds. And what happens there is the voltage can sit on, should we say, the load side of the terminals. And that voltage presence has been highlighted by others that it could cause a fault with protective devices. And that's why it's a bit of an issue with some solar sort of PV systems and some devices out there. All devices are different. So on the screen at the moment, what you'll see is the proposed regulation for the draft. So this came out sort of earlier this month for comment. And so they're proposing that where you've got bidirectional energy flow or power flow, that you take into account the device that you're using. And we've got a couple of definitions of that. Unidirectional, okay, our energy or our power is only going to flow in one way. So most of our circuits are unidirectional. Bidirectional, it's where energy or power goes both ways, and we need to take into account how we wire up those protective devices, because if energy flows both ways, we need it to function, we need it to open, we need it to make sure it's going to be great when things are bad. Okay, we don't want the device to fail and we don't want reduced capacity. And this is the big thing about checking with the manufacturer, the suitability of those devices. So why must we consider power flow? We've just touched on this, but they're designed to safely operate in the event of fault. So they may have reduced capacity if they're wired incorrectly. We've heard recently that what can happen if devices aren't wired up correctly, that it may affect some devices with their what we call their shunt, so that their tripping circuit, because there's some electronics involved in that, and we don't really want to damage that. So that's why we've the regulations are coming out to be changed in Amendment 3 to sort of let you know, let's use the right device here. And you should always check with the manufacturer. So manufacturers can design their products however they wish, provided they meet the standard. So it's completely proprietary how they achieve fault protection and additional protection. So you should always check with the manufacturer that the device is suitable for either unidirectional use or bidirectional use. So what circuits do we have to protect? And you may be surprised at some of these. there are many zero carbon or electrification circuits, okay? Generators, I know it sounds strange, we're talking about diesel and gas turbines, but they are supporting the grid for frequency response. They are part of our drive to sort of net zero away from, I guess, coal. Generators used for backup purposes, we need to consider those. Solar PV, we've mentioned solar PV, electrical energy storage systems, wind turbines, heat pumps, you know, immersion heaters, any electrification there. And then finally, we've got the EVs, electric vehicles, and soon the sort of vehicle to load, vehicle to grid that we're seeing. So we're going to use sort of that big battery on wheels. We're going to use that to power our homes as well. And that's not unique. That's being used today. So we need to consider where energy, where power flow goes for all these things. Do we need additional protection on every circuit? And from experience, the answer to that really is probably very few circuits require additional protection unless you've put cables in walls or you've installed it in a manner that requires additional protection by RCD. The simple thing with this is to design out that RCD element where it's not required. You may need them for fault protection, in which case you should find a suitable RCD to provide that. But in many cases, a circuit breaker conforming to 60898 BS88 fuses are perfectly viable to give you the protection you need, the ADS you need for that device. Also, designing out RCDs, especially with heat pumps, as an example, eliminates the need to consider inrush and earth leakage, which can be a big problem. A lot of manufacturers are stating that where you do need to use an RCD for additional protection, it should be a type B or a type F. It might be 20 to 30 pounds for a type A. It might be 200 to 300 pounds for a type B or F. So there's huge differences here where an MCB or circuit breaker will provide the protection you need without the use of an RCD. When we're considering RCDs, we should make sure that we select the right one. Okay. Not only do we need to look at if it's unidirectional or bidirectional, we need to look at, is it going to disconnect all poles? And that's been a basic requirement of regulation 551.7.1 anyway. So we need to make sure that all poles are disconnected. As we've mentioned, type A are now default and they're relatively sort of low in price. However, some solar PV and heat pumps do require that if you are going to use an RCD, that it should be of type B, which is quite common. Again, there's quite a price increase on those, and we need to consider how we wire those in, and we'll come on to that shortly. Don't be confused with the selection of RCDs and RCBOs, the protective curve, B, C, and D, with the sort of type A, type B, type F, etc. So just ensuring that we select these products right, otherwise it can be costly. Important that when we select and erect RCDs, they are the correct one and we put them in the right way. And we've got this image of our friends at BEMA who have a great guide on selection and erection of RCDs in general. And here it's clearly stating that if you're going to use a type B or a type F, that you really shouldn't be using an RCD in front of that because of blinding. So careful selection now. This may make a difference when you are selecting boards, different consumer units doing different jobs. You might have to split the tails, for example, but this is a great guide as well from our friends at BEMA. So where RCDs are required, it's really important that we select them in the right way and we wire in the right manner as well. Let's have a brief overview of other circuits. Bidirectional energy flow, power flow isn't just an AC thing. We can use it in other circuits. So RCDs are required. If they are a requirement, they should disconnect all live conductors. They should be a suitable type and meet suitable standards. And this was highlighted on a previous webinar that we've done. That's available for you to watch on catch up with our Demystifying EVs. A lot of manufacturers who manufacture EV chargers will use an equivalent or a built-in or a PCB type RCD. And it's come to light that not all of them will meet the necessary standards in full. If you don't meet the standard in full, you're not meeting the standard. So it's wrong of us to say it's only met in parts. So if you're in doubt when you're selecting built-in RCDs to equipment, contact the manufacturer and ask for the conformity and if they do comply. And if you feel they don't, it's perfectly fine to fit your own RCD for protection, one which does conform to the British standards and will operate safely. So we've dived into that before with a great webinar. If you've not caught up on that, I recommend that you do. Do we need to consider what we call essential circuits? Loss of main circuits. This has many different forms. Emergency power circuits, some people call them. I know as essential from sort of data center sort of history, but other people will call these different things. Do we need to consider what we're doing, for example, when we're running off an alternative supply, switched alternative supply? So not when we've got solar PV, because that's in parallel, but when we're running off diesel generators, other type of generators, battery storage. Do we need to make sure that our circuit protection works? Well, yes, we need to ensure that we've got the correct earthing systems in. And typically, these would be TNS systems, okay? And it's worth confirming that with the manufacturer and making sure you've got that neutral sort of earth relay or bonding in place. But we still need to consider, are our protective devices going to disconnect? Now, often with power electronics, small generators, battery storage systems, they don't quite have the oomph. They don't have the fault currents that we expect on our normal network. We're very blessed in the UK, believe it or not. We experience very high fault currents on our network, which gives us those really low fault loop impedances and rapid disconnection. If you do a protection study on most devices, you'll find they are clearing faults well under 0.1 seconds. They don't go to the 0.4 or 5 seconds that we're accustomed to. So rapid disconnection. Do we get that fault current levels with battery energy storage systems? No, not really. So we need to make sure that our devices will operate. And quite often we need to consider ADS for these and verify ADS. And that's typically where you'll see the addition of RCDs for fault protection to ensure that we still get those disconnection times. So if you are installing electrical energy systems, so battery storage systems, alternative switch systems like diesel generators, for example, the designer should verify that the protection's still going to work either on raw mains or on alternate load. And we've got some great forms we've just developed here at the ECA, which take into account switched alternate sources. So you can document your switch alternate source, and then you can verify your ADS measures, and you can accompany that with your electrical installation certificate. So that is a requirement. As we said, this isn't a requirement for parallel sources such as solar PV. Do we need to protect other circuits? Yes, absolutely. DC circuits require protection too. Okay, so battery strings, even battery storage in homes, you'll quite often see if it's probably more than one battery storage, sort of one battery system, it will require you to put effectively a DC fuse box in. Okay, typically with DC, we are looking at, I guess, the good old BS88 fuse, which is a robust fuse, takes power flow in both directions. But there are others, and it's worth knowing actually that sort of our 60898, our circuit breaker, our traditional sort of ordinary person circuit breaker, our MCB, they aren't commonly used on DC. We need to move towards the 60947-2 circuit protection for DC and confirm with the manufacturers that they're suitable. So, these devices are built for DC. It's really important that we get the right protection for our DC circuit. So solar strings, over 2 strings, again, protection against overload. We've been doing this in our cars, our caravans, our boats, etc. for years. We need to do this to our electrical installations too. And with the advent of more DC circuits in our homes, I'm sure it won't be too long till we start seeing DC distribution boards in our homes, DC consumer units. So just be aware that when you're dealing with DC, that needs protections too. So let's mop this all up. net zero and carbon technologies are plentiful, okay, and they vary by design. We need to consider where the energy is going, where the power is going, okay, and where there's voltage going to be present, okay, and that comes with actually selecting the right device. We need to make sure it's the right device for the right job, okay. We can design out requirements for additional protection where needed. We've been doing this for years. We don't tend to put them on submains and air conditioners, so heat pumps, etc., any sort of source of supply really. If we can just rely on our basic ADS, that's going to help us very much. And we need to verify if we've got, you know, two sources or multiple sources of supply and a sort of switch alternative. We need to ensure that the users of the installation itself is going to be safe for continued use, and, you know, no one's going to get any nasty surprises on that one. So we need to verify that under switch alternate load that those devices will safely operate. And that's a bit of a, you know, a whistle stop tour on protected devices, mainly around sort of net carbon zero. And now we'll come on to any questions that you may have.
Thank you, Darren. Just getting my webcam on there. Thanks for that fantastic presentation. I can't see any questions on my side yet on my screen. So anyone who has a question on their mind, feel free to just pop it in the questions box there, and well, I won't answer it, Darren will answer it. In the meantime, Darren, if anyone watching this, maybe watching it on playback later on, has a question, what's the best way to get in touch?
Best things for our members to get in touch is I've highlighted today. We've got lots of information on our YouTube channel. So demystifying has been a bit of a subject for our Technical Tuesdays. So we've got lots of that, and we've got more content coming. The ECA website. So for our members, log on to eca.co.uk/technical, and we've got all the forms I've mentioned today about the verification of ADS and working under alternate load, plus all our guides. That's free resource for our members too. And if members do have questions, they can call our technical helpline. We man that 5 days a week from 9 o'clock till 5 o'clock at night. So there's always a technical manager. So it's a unique feature of the ECA. We don't run a helpline team, we run a technical manager, and they're there to answer your phone calls and emails. You can email our support line at technical@eca.co.uk, and we will respond to that as well.
Brilliant, thank you, Darren. And just on the subject of net zero, I mentioned earlier our roadshow that we took around the country last year. That was very much an introduction into the work that we're doing to bring net zero up the agenda in the political space. On the comms, marketing, public affairs side, ECA is working really, really hard to make sure that low carbon technologies, but also the skills to install and maintain those technologies are as high up the agenda as possible for skills providers and for the government as well in general. So if you want to find out more about that, how you can take part, how you can make your voice heard, and to tell us how we can better represent your voice, that will be on the Taking Action tab on the ECA website. If you go to our homepage, eca.co.uk, you should see Taking Action just at the top right hand side there. We can wrap up there, Darren. I'm not seeing any questions, but like we said, if anyone has any questions, you can get in touch with Darren by email and we'll pick up your questions there. All right, and now we will conclude the webinar. Thank you very much, everyone, and have a great rest of your day.
Thank you all. Take care.